Hello, I'm Aradhana Sharma. I'm presenting my final project, classification of Iris Flower Dataset using different machine learning algorithms. This project was conducted under the advisement of Professor Dr. Hardik Gohel for the partial fulfillment of the course Data Science using Machine Learning. A quick note about me. I have a bachelor's degree in computer science from India. Currently, I'm pursuing Masters in Computer Information Systems at University of Houston, Victoria, Katy. I am a data enthusiast and I'm currently working as a research assistant at the Applied Artificial Intelligence Research Laboratory at UHV. I have 2 years of industrial experience as a developer and 3 years of teaching experience. The problem statement, I'll be illustrating classification techniques using machine learning algorithms. This work is a comparative study of 7 machine learning algorithms. Database used. I have used the Iris Flower dataset for this project. Iris dataset. The Iris dataset contains 50 samples of 3 iris flower species, namely Iris setosa, Iris virginica, and Iris versicolor. That means it has a total of 150 samples. The main characteristics of these species are the measure of the length and width of their sepals and petals. This dataset is frequently used for algorithm testing, classification, and clustering instances in data mining. The classification models have used the length and width of these petals and sepals to classify the sample in their respective flower species. The matrices that have been used in this project to analyze the performance of each of the algorithm are accuracy score, the number of accurate predictions divided by the total number of predictions. In other words, the percentage of values that have been correctly categorized. This is used to summarize how well a classification model performs. Second is the confusion matrix. It is a table that is utilized in classification problems to determine where the model errors occurred. The rows of the table correspond to the actual classes and the columns represent the predictions the model has made. This table makes it simple to identify which predictions were incorrect. Next matrix used is the classification report. Classification report has precision score, recall score, F1 score, and support for each of the classes. Precision score is the proportion of positively guessed numbers that are actually true positives. Recall score is the number of accurate positive predictions out of all the possible positive predictions. F1 score is the mean of precision and recall values. Support is the number of actual occurrences of the class in the specified dataset. Machine learning classification algorithms. Classification is a supervised machine learning technique where the model tries to guess what label is correct for some input data. In classification, the model is thoroughly trained using the training data and is then assessed using test data before being utilized to make predictions on new unseen data. The 7 different classification algorithms that have been used for this assignment are knife-based classifier. There are 3 different kinds of knife-based classifiers that have been used in this project. K-nearest neighbor classifier, logistic regression, decision tree, random forest, gradient boost, and support vector machine. Knife-based classifier. The knife-based algorithm is a classification method that relies on the Bayes theorem and assumes that predictors are independent. A knife-based classifier believes that the presence of one feature in a class has nothing to do with the presence of any other features. The probability that the event A will occur when event B occurs. The first naive-Bayes classifier is the Gaussian naive-Bayes classifier. This classifier is used when the features are not discrete. We use this classifier to classify the Iris Flower dataset, and here are the results. Class 1 had 100% accuracy. Class 2 had 2 data samples that were misclassified. Class 3 had 3 data samples that were misclassified. This gave us an average accuracy score of 0.933. Second naive-Bayes classifier is the multinomial naive-Bayes classifier. This classifier can be used when features follow a multinomial distribution. We used this classifier to classify the Iris Flower dataset, and here are the results. Class 1 had 100% accuracy. Class 2 had 1 data sample that was misclassified. Class 3 had 2 data samples that were misclassified. We have an accuracy score of 0.96 for this classifier. The third naive-Bayes classifier is the Bernoulli's naive-Bayes classifier. This classifier can be used when features are of Boolean type. We use this classifier for classifying the Iris dataset, and here are the results. Class 1 had 0 accuracy. Class 2 had 0 accuracy. Class 3 had 0.32 precision. There were 26 data samples in class 1 that were misclassified, 25 data samples in class 2 that were misclassified, and 24 data samples in class 3 that were correctly classified. It gives us an accuracy score of 0.32. This is the least accuracy that has been obtained during this project. This was the worst performing classifier. The next classifier is K-nearest neighbor, KNN. KNN provides predictions based on the vector created by the independent variables of the predicted values class density of nearest neighbors. The distance of the point to be predicted to other points is calculated. This is calculated using the Minkowski distance calculation function. K-nearest neighbor classifier is used for classification, pattern recognition, data mining, simple recommendation systems, and many more. We used this classifier for classifying the Iris dataset, and here are the results. Class 1 had 100% accuracy, Class 2 had 100% accuracy, and Class 3 has 3 data samples that were misclassified. We have an accuracy score of 0.96 for this classifier. Logistic regression. Logistic regression estimates the probability of an event occurring, such as voted or didn't vote, based on a given data set of independent variables. It tries to find the best line that separates the classes. It is very similar to linear regression because of its linearity. It is commonly employed in linear classification issues. Logistic regression can be used for classification and predictive analysis. We used logistic regression for classifying the Iris dataset, and here are the results. Class 1 had 100% accuracy. Class 2 had 2 data samples that were misclassified, and Class 3 again had 100% accuracy. We have an accuracy score of 0.973 with this classifier. Decision tree classifier. Decision tree is a supervised learning algorithm that is frequently employed in classification issues. It has a single node at the beginning, and it develops into a tree structure. It creates a model that predicts the value of a variable by extracting simple rules from data properties and learning those rules. Decision tree classifier can be used for prediction analysis, data classification, and regressions. We used this classifier to classify the Iris dataset, and here are the results. Class 1 had 100% accuracy. Class 2 had 1 data sample that was misclassified. Class 3 had 1 data sample that was misclassified. We have an accuracy score of 0.973 for this classifier. Random forest classifier. Random forest is an ensemble learning technique for classification, regression, and other problems that work by building many decision trees during the training phase. The class that most of the trees choose is the output of the random forest for classification problem. Random forest classifier can be used for classification and regression. We used this classifier for the Iris dataset, and here are the results. Class 1 has 100% accuracy. Class 2 has 2 data samples that were misclassified. Class 3 has 2 data samples that were misclassified. We have an accuracy score of 0.946 for this classifier. Gradient boost classifier. Gradient boost is composed of gradient descent and boost. Any differentiable loss function can be optimized by using the gradient descent approach. Each tree is constructed individually, and each tree's sum is calculated sequentially. The following tree tries to make up for the loss. Loss here is the difference between the real and anticipated value. Gradient boost classifier can be used for classification and regression problems. We use gradient boost classifier for Iris dataset classification, and here are the results. Class 1 has 100% accuracy. Class 2 has 2 datasets that were misclassified, and Class 3 again has 100% accuracy. Therefore, we have an accuracy score of 0.973 for this classifier. Support vector machine. Support vector machine looks for the optimum line that separates the classes, just like logistic regression. The green region within plus minus 1 of this line is called margin. The separation of 2 or more classes is improved by broader margin. The support vector machine predicts which side of the gap the new sample will fall. Support vector machine can be used for classification, regression, and outlier detection. We used this algorithm to classify the Iris dataset, and here are the results. Class 1 has 100% accuracy. Class 2 has 6 misclassified samples, and Class 3 again has 100% accuracy. The average accuracy score of this algorithm was 0.92. Here is a table that shows the summary of the accuracy scores of all the algorithms used in this project. Gaussian naive Bayes classifier has an accuracy score of 0.933. Multinomial naive Bayes classifier has an accuracy score of 0.96. Bernoulli's naive Bayes classifier has an accuracy score of 0.32. K-nearest neighbor has an accuracy score of 0.96. Logistic regression has an accuracy score of 0.973. Decision tree classifier has an accuracy score of 0.973. Random forest classifier has an accuracy score of 0.946. Gradient boost classifier has an accuracy score of 0.973. And support vector machine has an accuracy score of 0.92. Conclusion. The best accuracy score obtained during this assignment was 0.973, which was achieved in 3 different algorithms: K-nearest neighbor, logistic regression, and decision tree. The worst accuracy score was obtained in the assignment 0.32 for Bernoulli's naive Bayes classifier algorithm. This algorithm is more suitable for dataset where the features are of Boolean type. All the algorithms have given an accuracy score above 0.9. Hence, any of the algorithms except Bernoulli's naive Bayes classifier can be used for similar dataset. From this project, we conclude that Bernoulli's naive Bayes classifier is not a suitable algorithm to be used for any dataset that is similar to Iris Flower dataset. Whereas the other classification techniques can be used for datasets similar to Iris dataset, as they give an accuracy score above 0.9, which is considered to be a good accuracy score. Thank you for your time and attention.